Okay, continuing our discussion on Chapter 2, Lesson 4, I want you to turn in your 2.4 notes and go to Example 6. Okay. Example 6 focuses on the fundamental theorem of algebra. It says a polynomial function of degree n has exactly n zeros, including repeated zeros in the complex number system. Okay, this is followed up by the linear factorization theorem that says if f of x is a polynomial function of degree n bigger than 0, then f has exactly n linear factors. Okay. What these mean is if I have x to the 4th power, then that function has 4 zeros. Okay. The zeros could be real or they could be in the complex number system, meaning they contain imaginary numbers. And that also includes repeated zeros. But it would have 4 zeros and 4 linear factors. So every polynomial function can be written as what we call a linear factorization of all of its factors. Now we're going to use this idea to write a polynomial function given the zeros of the function. Remember, the zeros are the values that we get for x. They could be real or they could be imaginary. So we have write a polynomial function of least degree with real coefficients in standard form that has -1, 2, and 2 minus I as zeros. So what I know is a polynomial function. When we solve for x, we get x to equal -1, we get x to equal a positive 2, and we get x to equal 2 minus I. Okay? So we have 2 real solutions, and we have a complex solution or an imaginary zero. Now, the conjugate root theorem states that if a plus bi is a zero of a polynomial function, then its conjugate a minus bi is also a zero. So if x equals 2 minus I is a zero, then from the conjugate root theorem, x equals 2 plus I is also a zero. What I'm doing is I am working backwards from when I factor. Typically, when I factor, I have my polynomial function, I find my factors, and I solve for x. Well, this time I have x, I find my factors, and then I multiply to make the polynomial function. So the first thing I have to do is set each of these values equal to 0. I will do so by adding 1 to both sides. So we have x plus 1 is equal to 0. I can subtract 2 from both sides. And we have x minus 2 is equal to 0. Okay, for my complex 0, I'd have to subtract 2 from both sides and add I. So we have x minus 2 plus I equal to 0. Okay. For my second complex 0, I have to subtract 2 from both sides and subtract I from both sides. So we have x minus 2 minus I is equal to 0. So to write this as a product of linear factors, we have f of x is equal to the quantity x plus 1, x minus 2, x minus 2 plus I, and x minus 2 minus I. Now, I need to go through and FOIL. I'm going to FOIL the 2 binomials together, and I'm going to FOIL my complex factors together as well. So starting with the binomials, x times x is x squared, x times -2 is -2x, 1 times x is x, and 1 times -2 is -2. Then my complex zeros, x times x is x squared, x times -2 is -2x, x times -I is -ix, -2 times x is -2x, -2 times -2 is a positive 4, -2 times -I is a positive 2i, I times x is ix, I times -2 is -2i, and I times negative I is negative I squared. Now simplify each quantity, and we have x squared minus x minus 2. And for my second quantity, I have an x squared. I'm going to cross out the x squared. A negative 2x and a negative 2x make negative 4x. Negative ix and positive ix is 0. 2i and negative 2i is also 0. So notice the i's have been eliminated when I multiply the conjugates together. Then I have 4 and negative I squared. Remember, I squared is negative 1. So the opposite of negative 1 is a positive 1. 4 plus 1 is 5. Last, I'm going to FOIL these two quantities and distribute, starting with the x squared. X squared times x squared is x to the 4th power. X squared times negative 4x is negative 4x to the 3rd power. X squared times 5 is 5x squared. Negative x times x squared is negative x cubed. Negative x times negative 4x is positive 4x squared. Negative x times 5 is negative 5x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is a positive 8x. And negative 2 times 5 is negative 10. Now, we finish up by combining like terms. Okay, I start with the highest power, which is x to the 4th. Then I have negative 4x to the 3rd power, and negative x to the 3rd power, that is negative 5x to the 3rd power. Then I have a 5x squared plus 4x squared minus 2x squared. 5 plus 4 is 9. Minus 2 is a positive 7x squared. Negative 5x plus 8x is a positive 3x minus 10. So this is the polynomial function that has the 4 zeros, x equals negative 1, x equals 2, x equals 2 minus I, and x equals 2 plus I. Okay, I would like for you to try number 6, letter A. Now keep in mind we have negative 3, 1 with multiplicity 2, and 4i. So what I know is that x is equal to negative 3. Now if it has multiplicity, it is repeated. So if x equals 1 has multiplicity of 2, it occurs twice. So we have x equals 1 2 times. Now we also have x equals 4i, but we have to include the conjugate from the conjugate root theorem, so we also have x equals negative 4i. Now make sure you set each quantity equal to 0 and use those factors to multiply to make your polynomial function. Good luck!